All right, ladies and gents, tonight we're learning how to graph equations on a coordinate plane. So go ahead and put your name and the date on your paper if you do not mind. So this right here and this right here is a coordinate plane, which I'm sure you've seen many a times before. We call it a coordinate plane because we graph different types of coordinates on it using the x and the y axis. I'm sure you guys have used a coordinate plane before, so we're going to do a quick review of something really quickly here. Get it? Quick, really quickly. All right, looking here on our first one, I'm going to use two different colors for this, so you might want to do the same. Everything on this side of the coordinate plane for the x-axis is positive. So any positive numbers you would graph over here for the x-axis. So if you had to move over 1, 2, 3, 4, you had to move over 7, if you had to move over 10, you get the point. If you had to graph a negative number on the x-axis, you would graph it on this half of the coordinate plane. I'll mark that one negative. So if you had a negative x number, you would mark it going this way. -1, -4, -7, -10, and so on and so forth. Over here, we're going to do the same thing for the y plane. After you graph a number on the x-axis, you would graph your y point. If you're counting up with a positive number, you're moving up the y-axis, which means everything on top. Let me hold my paper for a second. Sorry for the close-up. Everything on top is positive. If you're graphing a negative number on the y-axis, you would have to go below this 0, 0 mark. So -1, -4, -5. Which makes this negative. I know some of you are probably thinking, what? And some of you are probably thinking, duh. That's just going to help us as we move forward. Once we start graphing these, that's going to make some more sense to you. So first we got to get to the point where we know what to graph on a coordinate plane. So to graph equations on a coordinate plane, you solve using input and output tables, which if you flip your paper over are these tables on the back where they give you a value and an equation and you have to figure out what the y would equal. So in this case, if the rule is subtract 3, it's whatever your x is minus 3, which we'll get to. But that's an input-output table. When you do the input-output table, the x is always the input, the y is always the output. This is where you're always going to graph your x. This is where you're always going to graph your y. It won't always be labeled, but for the first few days as we're working with this, they will be. When you solve your input-output tables, it's going to give you an ordered pair, which I know you've plotted on coordinate planes before. Once you see them, you're going to be like, oh yeah, I totally remember that. Remember, whenever you start graphing your ordered pair, you're going to graph the x-axis first. And the way I remember it is if you're thinking about hanging Christmas lights or cleaning a gutter and you have to use a ladder, you always want to move your ladder to the part of the house, to the right or the left where you want it, before you climb up it. Because if you climb your ladder and you're not in the right spot, you're going to have to climb back down again. So you always move right or left before you climb up or down. All right, we're going to try this one on the back together. So this is our example. So our rule for this one is to add 3. So in this case, our y, or our output, we're going to find when we solve the equation x plus 3. Now our x is going to be on our input box, which is right here. So our first one says 2 for the x. If I plug 2 into this equation, I have 2 plus 3, which equals 5. That gives me an ordered pair of 2, 5. Over here on the graph, I would graph that starting at 0, 0, I would move to the right 2 because it's positive, and then up 5 because, again, it is positive. And I'd plot that point right there. If you want to write 2-5 over it, you can. You don't have to do that, though. Our next input is 4. If we plug that into our equation, we get 4 plus 3, which is 7. For our ordered pair, we look at our x first, which is 4. We look at our y, it's 7. Again, we're going to plot it. We're going to count over 4, 1, 2, 3, 4, and up 7. 1, 2, 3, 4, 5, 6, 7. And I'm not going to put the 4-7 over it because it's going to make my example a little congested, but if you want to, you go right ahead. Our next one, our input is 6. When x equals 6, what does y equal? Well, if we plug it in, 6 plus 3, we get 9, which makes our ordered pair 6-9. We would go over 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4, 5, 6, 7, 8, 9. You'll notice I'm not drawing a line between these because we're not making a line graph, we're plotting the points on the graph. I'm going to pause the video, or I'm asking you to pause the video to solve this last part by yourself. Once you finish, go ahead and hit play so that you can check your answer. All right, you must have the answer. Oops, sorry, there's the bell. If x equals 8, what is our y? Well, we have 8 plus 3, which is 11, which makes our ordered pair 8, 11. We go over 8, 1, 2, 3, 4, 5, 6, 7, 8. Oops, 1, 2, 3, 4, 5, 6. And then up 11. 1, 2, 6, 7, 8, 9, 10, 11. We almost ran out of room there. Good thing we stopped. All right, go ahead and try those last 2 on your own. You're lucky I didn't give you anything that's going to be on the negative side today, but you're not going to be so lucky tomorrow. See you then.